Hello, this is Mrs. McCahan, and in this video I'm just going to introduce the concept of factoring. And I want to recap how we solve quadratic equations. This is what you learned in Algebra 1. So in Algebra 1, you either graphed the parabola and you found the x-intercepts where it crossed the x-axis, or what you commonly use algebraically is the quadratic formula. And I'm sure you remember that long formula, the x equals negative b plus or minus square root b squared minus 4ac all over 2a. Right? Yes. It's a very long formula. I'm sure you guys are groaning right now. But some other options, and I don't know if you learned this in Algebra 1 or not, but some other options that we have are completing the square, which I will teach to you guys later in the semester, and also factoring. So factoring is one of the ways that I'm going to show you that I'm going to focus on right now. So idea of factoring. If we go forward with these two problems, we would distribute the 2, right? So if I would go forward, this would be 2 times 3x is 6x, 2 times 1 is 2, and this would be my answer. Well, factoring will start with this. It would start with this answer and would want to go back to here. Okay, same thing with down in this problem. This is just two binomials and we would distribute. So I would distribute the x, 2x squared plus 3x, and then distribute the negative 4, negative 8x minus 12. And then we would combine like terms. And we would get a trinomial for our answer. Well, again, factoring, what it does, it says, I'm going to start here. I'm going to start with this answer, and I want to know what was this before I distributed. Okay, so that's all factoring is the inverse operation of distributing. So I'm going to focus on that first type in this video, and then there will be other videos dealing with this second type and more complex versions of that. So when you're factoring, I highly recommend you always look for common factors first. So you're always looking for that first type of problem where you distributed something to every term in the problem. Okay, so when we're going backwards, remember when we were distributing, we were multiplying everything. And so now if we're doing the inverse operation, it makes sense that we would be dividing everything. So what can I divide all of these terms by? I want the highest common factor. So if I look at just the coefficients, 24 and 8, the highest factor that will go into both of those is 8. So I can divide both of those by 8. And then you also have to consider the variables, x squared and x. Okay, I can divide both of those by an x. And again, you don't have to write this, but this is what my thought process is. So I know I'm dividing both of those by 8x. So whatever I'm dividing by, that's going to be what goes in front of my parenthesis. And then after I've divided, that's what goes inside of the parenthesis. So when I do 24 divided by 8, that is 3. If I do x squared divided by x, that is just x. Keep in mind, if that's confusing to you, x squared is x times x, and I'm dividing by an x. So one of those cancels, and all I'm left with is a single x. Over here in this term, 8 divided by 8 is 1. And then x divided by x, that cancels out, so there is no more x. And then you can always double check yourself. So this is what I would have as my answer to my factoring problem. And I could check it if I wanted to and by distributing. Okay, so if I were to check this, this would be, yes, 24x squared plus 8x. That's what I started with. Okay, so this was like a check. Okay, so that's how we do greatest common factors. I call that GCF. Okay, so if I ever say, what's your GCF, or did you look for GCF? That's what I mean. Okay, let's do another one. In this one, what can I divide each of these by? Okay, well, it looks like a common factor is 5, so I can divide each of these terms or the number 5, do you notice in the variables, this first one has an x squared, then an x, and then no x. So I don't have a common variable, so I'm not going to be dividing by an x this time. All right, so if I'm dividing everything by 5, that goes in front of my parenthesis, and then what I have left would just be 1x squared, and then 3x plus 2. Okay, and again, you can double check yourself by distributing. Now, this inside of here can be factored even more, and I'll get to that in another video. But for right now, I just want to focus on greatest common factors. So I want to have you guys try these two. So pause the video at this time, and then when you unpause it, I'll have the answer come up and I'll explain it. So in this first one, I have boxed in my answer. I divided each term by 3x squared. And so you see my 3x squared in front, and then 9x squared minus 1 in the middle. Also, this is still factorable. And again, like I said, I'll get to that in another video, but for now, we're just worried about getting it into this form. Okay, and then down here, how did you do on this one? This one, did you notice that I can divide these first two terms by 2, but not the last one? So I couldn't do a coefficient in this one. I could only divide by a common variable. So we divided everything by an x, that came out front, and then each of the powers in the terms just was reduced by 1. So I have 2x squared plus 6x minus 1. Now, this is all greatest common factor, and remember I said that this was factoring as a way to solve. So how does this help us solve? So let's say, I'm going to go back to our first example. So let's say I had this quadratic, and I was trying to solve it, meaning I had the problem 24x squared plus 8x is equal to 0. So one way we can use factoring to solve is we use our factoring, our greatest common factor, which is, when we factor that, that came out to be 8x times the quantity 3x plus 1, and that was equal to 0. So what do you do at that point? Because you factored it, but then what do you do now? It's still an equation and we haven't solved it. So remember our zero product property. That says if I have two numbers, let's say I don't know them, so a times b equals 0. What do I know about either a or b? Well, I know that at least a has to be 0, so I would either have a times b is equal to 0, or I would have a times 0 is equal to 0, or I could have both of them equal to 0, right? 0 times 0 is equal to 0. But the zero product property says at least one of them has to be 0, if not both. So we're going to use that idea. Instead of a times b, I'm going to erase this now. Instead of a times b, I have my two factors, right? So I have 8x is like my a. Think of this as like my a. And then I have my 3x plus 1, that's like my b. Well, if I know at least one, if not both of them have to be 0, then I would say, okay, 8x could be 0, or 3x plus 1 could be 0. So now I have two different equations and they're linear, and I can just solve them. So how would we solve this one? We just divide by 8, and I get x equals 0. Over here, we subtract the 1 and divide by 3, and I would get x equals negative 1/3. Okay, so these would be my two answers of my quadratic equation, or in terms of graphics, right? Graphically, I know this parabola would cross the x-axis at 0, x equals 0, and x equals negative 1/3. So that's your introduction to factoring. In other videos, I'm going to do more types of factoring.